In chapter 2.8, we're proving angle relationships. And there are two basic postulates for working with angles. The first one is the protractor postulate. So it's protractor measures. Right? So this is very similar to chapter 2.7, where we had the ruler postulate, right? Which measure the number of degrees in an angle, using a protractor. All right, and so here the next one is the angle addition postulate. So this is the angle addition postulate. Relates parts of an angle to a whole angle. And so just like in chapter 2.7, we had the segment addition postulate, right, which said that a segment is equal to the first part plus the second part. Right? We have the angle addition postulate, which lets us say that if we have this angle here, the bigger one. Right? So it's a counterpart to the segment addition postulate. And so whenever you see a figure that looks like this, we need to apply the angle addition postulate in order to get our equation so that we can use our algebraic properties. Right? Again, like in 2.7, how we ignored the ruler postulate, we're going to ignore this protractor postulate, just take it for granted. Right? We don't need it as a reason for one of our proofs. What we need is angle addition postulate. This is the star of this show. Okay, and so the two postulates can be used to prove the following theorems. Right? So if two angles form a linear pair, then they are supplementary angles theorem. Right? If the non-common sides of two adjacent angles form a right angle, like these two here, right, FGJ and JGH form a right angle, then the angles are complementary angles. Right? So remember, complementary is 90 degrees. 90 degrees. And this is the complementary angles theorem. Complementary angles theorem. Okay. So complementary angles theorem lets us say if we have a figure that looks like this, that angle 3 plus angle 4 is equal to 90 degrees. Right? The supplementary angles theorem says if we have a figure that looks like this here, that looks like that, then we could say that angle 1 plus angle 2, or the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. Right? If they form a linear pair. Alright, so we're here in example 1, and so if angle 1 and angle 2 form a linear pair, and measure of angle 2 is 115 degrees, find measure of angle 1. Right? Well, applying the supplementary angles theorem, because we do have a linear pair here, we could say that the measure of angle 1 plus measure of angle 2 is equal to 180 using the supplementary angles theorem. Then we could substitute 115 in the place of the measure of angle 1. Right? So we'll say measure angle 1 plus 115 is equal to 180. Then we're going to subtract 115 from both sides, and we get measure of angle 1 is equal to 180 minus 115. And finally, measure of angle 1 is equal to, what is it going to be, 65 degrees. And now here we have example 2. And so here we have angle 1 and angle 2 form a right angle, and measure of angle 2 is 20. Find measure of angle 1. And in this case, we're going to apply the complementary angles theorem. It says that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees if they form a right angle. And now we're going to substitute in our 20 for measure of angle 2. Right? So we'll get measure of angle 1 plus 20 is equal to 90. And then we're going to subtract 20 from both sides, so we'll get this. And then lastly, we'll have measure of angle 1 is equal to 70, like so. And we're done. So what are we introducing in this chapter? It's the angle addition postulate. Right? If we have a figure that looks like this, we could say that the first angle plus the second angle is equal to the measure of the entire angle. We have supplementary angles theorem, which says if we have a linear pair, it looks like this, that measure of angle 1 plus measure of angle 2 is equal to 180. And the complementary angle theorem that says if we have a figure that looks like this, then measure of angle 3 plus a measure of angle 4 is equal to 90. And so we're going to be using these reasons in order to create our equations when constructing our proofs.